palfun-foslup. Yes, everybody.
Thank you. Thank you. Thank you. Okay, thank you all for coming. This is only like halfway through the first day, and it's already lived up to the hype from what I heard about last year. So it's been great being here with you all. I want to talk today, and I should actually take this off, the Tacen hat, because this isn't really a Tacen project. This is something I've been working on in my spare time for PalDev on and off for quite some time now. And I want to show you all like what it is about. I can't really like show you a product and be like, oh, we're launching today, because it's not. It's complicated. You'll see. So it's been a slow burn project, and I want to talk about it. But before we do, I want to talk about something like more grounded in the absolute state of Urbit, which is composability. We talk about this a lot in our marketing materials, where it's like, oh, if you have apps on Urbit, like they compose together so easily. If you're a developer, you can add integrations with all these other things trivially, and well, it's honestly not all it's cracked up to be. I wouldn't go as far as calling it a farce, but there's still a lot of work to be done there. If we look at the developer-facing side of this, yes, you can compose with other applications. You can get data out of them. You can send them commands. But it's all kind of ad hoc in a way. If I want to send a command to your application, there's no way for me to know dynamically what commands you support, what version you're on. If I want to read data, well, subscriptions aren't discoverable. The Scry interface has affordances for it, but you kind of depend on the developer of that application implementing part of that discovery functionality for you, and so in practice it just doesn't exist, right? What this means is that while, yes, we have composability, but it's not dynamic composability. It's always manual, it's always ad hoc. You have to pull up either the documentation if you're fortunate, or the source code if you're less so, to see what affordances other applications provide and how you can hook that into your own software. And as far as user-facing composability goes, it just straight up doesn't exist. Like, there's no such thing. All of the same problems that we have with developer-facing composability, of course, bubble up. And even if we had solved for all of those, you have to answer the question of legibility. If an application says, yes, you can poke this with the chat update mark, user doesn't know what that is, what that contains. What data do I put in there? What are the constraints here? And what exactly is the behavior that's going to come out of that when I try issuing that? So this project has been, in some sense, about solving for all of these things. And not in a grand, like, oh, I have a new vision for how user space is going to work kind of way. No. The PalDev school of app development has always been very much about making do with what we have right now, rather than expecting that something will get built and then complaining to the Gore developers when they take too long. So you already saw some of this in the title slide, like automating your Urbit. There's a very natural shape that this takes. Can I get a show of hands of who here knows what if this and that is? And have you all used it? Yes? OK, that's a good amount of people, actually. For the few of you who don't know, if this then that was, or still is, I suppose, a Web 2.0 service where you can create an account with them and then connect your account from other services to your account with them. Their promise is that they say, oh, all of these other services expose APIs, and so we can do programmatic interaction with those for you. We deal with the complicated API wrestling, so you don't have to. You just come to us and say, hey, keep an eye on the technology subreddit. And if there is a post with Urbit in the title, then send me an email. or maybe tweet it out through my Twitter account. Of course, with the general decline of Web 2.0 and the whole open API world, all of this has very much declined. If this then that themselves now have a freemium model, where if you want more than 2 such automations, you have to pay them a monthly fee, and I don't think they're doing too well with that. But that doesn't actually matter, because if this then that, but on Urbit, is a much more compelling promise than they themselves could ever make, right? So that's the general setup of what I've been trying to build. And trying really is the key word there. I've done a number of prototypes on this at this point. The first prototype was way too ambitious, tried to do it all, and focused on the wrong things in doing so. There were some cool ideas there, but in the end, it never actually even worked. I had to scrap it completely. The second prototype dramatically reduced the scope, said, OK, here's a very limited set of functionality that we're going to support. And that at least works. That's a scope you can implement and test out. And so that is what I want to be showing you guys today as a little demo to at least give a sense of what using this on Urbit could look like. So we have some very big apps here on the left. This is Zod on the left. We have its terminal output here. On the right, we have fun. We'll get to that in a little bit. So in this little app here called Auto, we want to make an automation flow that says when someone adds me as a pal, I want to add them as a pal also. Because a friend of me is a friend of me. We're all mutuals here, right? So let's start. We'll make a new flow. And when we create a new flow, we first have to choose a trigger for this flow, the thing that's going to decide when this thing will run its logic. So we have a couple options built in here. We could run it periodically. In this case, we want to look for incoming pals. We select it and get a little description that watch for incoming pals means that this triggers whenever you get added or removed by someone. We proceed. OK, we can filter the trigger output. We'll talk about what exactly this means in more detail later. But for now, we want to say that we extract the ship from the pals change. And this actually gives us some options. We can specify what kind of change we want to take the ship from. In the case of someone adding us as a pal, we want to add them back only if they add us. If they remove us and we weren't already pals, then we leave that be. We proceed. And lastly, we get to actions that we want to trigger when this runs. Get the dropdown again, and we can say add a pal. Adds the given ship as a pal. Takes no inputs. Easy as. Let's say we also add another one, just for verbosity, where we say we also want to print output to the terminal when this happens, so that we can get a little visual notification. New friend. We save this. Finally, give this flow, automation flow, a name. That's still caps, but it's fine. We save this, and we go back to the overview of the list of automations that we have. Now, this says last run never, because nobody's ever added Zod as a pal, surely. But let's now do this from fun. We say Zod, at them, and right away here in the terminal, we see new friend, fun. On fun's end, when it first submitted the request, Zod hadn't received it yet. But if we now refresh this page, we can see that it immediately became a mutual. Likewise here, if we refresh this, we can keep track of the last run of this trigger, which was 15 seconds ago. That concludes the demonstration. OK, so that's where this is at. It's somewhat limited. We'll see exactly how. But I think it's an interesting case study for what we can learn from how this was built for doing automation on Urbit. And so let's dive a little bit more into the structure of the flow that we saw just now. Every automation flow is made up of 3 main parts. We always start with a single trigger. Some data comes out of that. We call that a fact. That goes through any number of transformers. And lastly, the data we end up with triggers any number of actions. Let's start by looking at triggers. Here we have the type definition for triggers. And we have just 3 very, very basic affordances here. This is also good areas when you're prototyping to reduce the scope. Like maybe, you want to keep an eye on your state of network traffic or your file system. It's like, no. Just do the simple things first. So that's what I did. You can kick it as a user to manually give it input and tell it, hey, please run this automation flow. You can put it on a timer, say it needs to fire at a specific date time, and maybe repeat once every day. Lastly, and most expansively, you can say, I want this thing to trigger whenever this user space subscription gives me a new update. This is what we used for the PALs example just now. So the data that comes out of that is somewhat constrained. You see here that just like we had kick, time, and peer triggers, we can get kick, time, and peer output from those same triggers. For subscriptions, we can also quit, like the subscription may be rejected when we open it. Let's not worry about that for now. The last option here is interesting, the one called cache. It says scripted values. This is important because it gives us a data format that we can make legible and present to the user. A cache is just a list of dimes, naturally, where a dime is atoms marked with their auras. So we say we have individual pieces of data, and we know this one is a date, this one is a ship name, this one is a piece of text. We can show that to the user, no problem. The user knows what a date is. The user knows what text is. They can handle that. Crucially, we also define something called a bill. This lets us specify the different shapes of in and outputs, the different shapes of facts that any given component, any transformer or action accepts as input or produces as output. This is important because it lets the user interface say, oh, you have this whole list of potential actions installed on your ship. But the data we're dealing right now is just a ship name. That's not going to make sense to put into something that increments a number, right? But it is going to make sense to put into an action that says add this ship as a PAL. We'll see how this comes into play with transformers. But first, we got to talk about marks. Because the obvious interjection here is, it's data on Urbit. Like, just use marks, mark data. It's great. OK, I get it. I appreciate it. But also, marks are kind of fake, and they're not legible. I say they're kind of fake because, especially in this case, the data is not actually going over the network. It's staying on our local ship. We never need to run validation on it. So that's one of the use cases for marks that doesn't even apply here. Secondly, marks are often too broad or too narrow. If I subscribe to chat and someone posts a new message, OK, I'm going to receive the chat message on the subscription endpoint. But is that going to come in with the chat message mark or with a mark that says chat update? And I'm going to have to figure out if it's actually a chat message or not. And even then, what does it mean to be a chat message? What exactly is in that? You might have more narrow marks, like, oh, this is a ship or this is an atom. But that still doesn't account for cases where I might want to deal with both the author and body of a message, but nothing else. That's just 2 atoms, right? But if I want that or the combination in reverse, or maybe the timestamp is in there somewhere, suddenly I have to have 50 different marks to deal with various parts of chat messages. And so then you end up with very ad hoc, poorly documented, probably weirdly named marks for which it isn't clear like which ones, how they transform into each other. The point about legibility is also very important. We care about how we can present this to the user so that the user can reason about it themselves. The thing we do when we say, oh, this is just a list of atoms with their auras, is we always know we can make it legible to the user. Again, the user knows what a date is. The user knows what a ship name is. OK, that out of the way, let's look at transformers. Where triggers were always static, there's just 3 options you could pick from. Transformers are more dynamic. They always have a function inside of them that takes one piece of data that comes out of a trigger or a previous transformer, and it spits out a new piece of data. So maybe we have one that increments a number. Crucially, the transformers come with bills to specify what shapes of input they support and what shapes of output they might give. So for incrementing a number, naturally that takes a single atom, pad UD, spits out another atom, pad UD. For the PALS example we saw earlier, we had a transformer that took the subscription update and said, OK, we'll take this thing and unpack it for you to turn it into a ship name. We'll turn it into something the user can actually reason about. Lastly, we end up at actions. Actions are a combination of static and dynamic. Obviously, it's legitimate to do nothing. Obviously, it's legitimate to do multiple things at once. The real power starts when you say, OK, we're going to poke other applications on your ship with some cage that we've constructed. We might display the output in the terminal also, or an automation flow might decide to disable itself under certain conditions. The last one here, take, is where you get the dynamicity again. Here, too, we specify what inputs we support, and then have a function that turns those inputs into an action to run. For the PALS example, this says we take a ship, and we'll construct the poke that goes to the PALS agent so that it can actually trigger the desired behavior for you. Now, that's the overall structure of these automation flows. And some things immediately, obviously fall out of this. It's very linear. It's very restrictive. And it all happens in one event. There's no asynchronous processing. We're going to talk more about why that is limiting and what I want to do about it in a little bit, but I wanted to point it out right here while it's still fresh in your minds. The other question we haven't actually answered yet is, where do these things come from? We saw we had a little drop-down in the UI earlier with some options. And printing to the terminal is a built-in functionality, but adding PALS certainly isn't. So where do we get that from? We get that from something we call a yard file. Here's the type definition for that. A yard file, no relation to Neil Davis's proposal. A yard file lives at a specific path on each desk that you have installed. And it contains simply a map of parts, where a part might be a trigger, or a transformer, or an action. These always come with names and descriptions, again, so that we can tell the user what this does. We can give them instructions about, use it in this context, this behavior will trigger, et cetera. And sometimes they come pre-built. There's nothing to change about them. So for make there, that's the easy case. It's completely static. It might also be variable, though. Like we saw, the one that extracts a PAL from a PALS update took a little piece of configuration that said, do you want to get the ship out if they added you, or if they removed you, or for both cases? In that case, the configuration, too, is tightly specified in a way that we can make legible to the user. The vars here is very similar to the build that we saw earlier, where it's just an aura of an atom and a name and a description again. So if we want a flag, we can simply give the user a checkbox in the UI. If they want a date picker. An interesting side effect of making these things configurable while still wanting to figure out which things can slot together is that we have to run the verification of like, oh, does it make sense to increment a number with this input, for example. We have to run that both before and after we apply the user's configuration, because the arguments that the user supplies might change the behavior of the thing. It's a little wart on the system already. It's clearly not entirely baked. Just as a real quick example, this is what a very simple yard file would look like. Here we have one trigger where we say, oh, we're going to subscribe to pals to listen to updates about incoming pals. And then we have a single action that says add pal, notably takes a cache that I didn't update properly for this example. It should say there cache send p without the TA. Take just a ship name, and then here's a function that ingests that ship name and creates the poke pals command for adding them as a pal. Now, OK, this one's a little bit more of a stretch, but there is another interjection here. What about generators? Because at least for actions, in some sense, generators fulfill the same role. They're a file at a specific location that specifies what you can do to, or like a command for interacting with the application whose desk it belongs to, or whose folder it belongs to. Here again, we return to the legibility argument, where technically we could get the type of the generator's arguments out of its gate, but how do we show that to the user? How do we make them reason about that? How do we make that legible? And if you're lucky, the first line of the generator has a little comment that describes what it does and what behavior it triggers, but often you're not quite so fortunate. We do share an interesting property with generators, though, in that both generators and the yard file can potentially be used by other applications. So I'm gonna put this thing back on real quick, because at Tlon, we've been talking for a little while about integrating more things into groups, specifically making groups such that, like by default, without any further work on our end, it lets you interact with other applications. It's not difficult to see if you're like, oh, we're in a very inline context, right? Like chatbots, maybe you have little inline modals for that. It's not difficult to think of slash commands and say, oh, if I do slash desk, that's then going to search that desk for a yard file where actions might be present. And then it's slash desk, the name of the action, and it has a little autocomplete or a pop-up to help me fill out the arguments for that action. OK, so all of that said, this is still very much a prototype. This is not production ready. It's difficult to work with. It's very limiting. It's not great. I have a couple of ideas for how to improve this, but unfortunately, that means that the scope must creep. The first one, which I think is very important for many different use cases, is that flows need to be able to store state. A fun example I came up with recently is that if I'm hosting a chat, I don't want people cursing all the time. So maybe we keep track of who curses and how often, right? And then if that frequency crosses a certain threshold, we just boot them. Not even a warning, we just boot them. But to be able to do that, we have to be able to, count per ship, maybe keep timestamps around, do calculations on state that we already had, and move that forward. Right now, there's no such affordance. So we want a mechanism by which logic in any given automation flow can get out its previous state, or maybe even state stored elsewhere, operate on that, and then put it back in somehow. The other important addition is asynchronous computation. Like I mentioned, right now, every automation flow, once it's triggered, runs within a single event. But if someone curses and then immediately apologizes or deletes their message, I don't really want to count that against them. So I want to be able to wait for 10 seconds before I continue with the rest of my logic. Or maybe for the decision making, I depend on data that I have to retrieve over the network from another ship. That does mean we have to answer questions here in the same way that Spider has to answer questions around, like, well, what if something is running and there's an upgrade happening? Like, the thing that's running might not be compatible with the new model. We will probably end up with a similar answer where we say, yes, we'll run these for you, but we can't make a full guarantee that this thing will continue running indefinitely as things keep happening to your Urbit. I'm not quite sure yet if that's exactly the right answer, but it's definitely the most obvious option open here. Advanced branching is another big one. Like we saw, flows currently are very linear. The most amount of branching you can do is say, oh, this transformer failed to produce a result. And so, yes, there was a trigger, but we don't really reach any actions. It's something, but we don't surface that to the user, and there isn't much they can do with that anyway. You really want something where it's like, oh, I want to do both of these things, or one of this thing based on this condition, and then maybe continue branching off of there based off of whether the poke to pals, for example, actually succeeded. This one, I think, is the one that's actually going to enormously explode the scope. If for nothing else but the fact that if you do that and you want complicated branching, well, we're going to need a UI that renders a cute little tree with like elements the user can drag around and stuff like that, right? It's going to be a whole thing. We'll get there. Lastly, I'm not sure what to do about transformer proliferation. I talked about how a chat message might contain a number of different things, and I might want parts of that in various combinations and in various orders. So do I really need multiple transformers for getting just the author out of the chat message, and the author and a timestamp, or maybe the timestamp and then the author? There's answers here in the direction of, yeah, you provide some transformers that give low-level operations on the data that you already have, like reverse the order of this thing or take out the second item, things like that. But again, you're going to be showing that to the user at the end of the day. And yeah, maybe you end up in a place where you teach them about nouns a little bit, and it'll be fun and educational and productive for them. I'm not sure yet what the right answer there is. And there's a bunch of things here I haven't mentioned. Obviously, you want to be able to create templates for this and share them with other Urbit users. Obviously, you want to be able to bring your own Hoon code and write a little component in line. All of that stuff matters. All of that stuff is very important. But it's not part of the core engine of this thing. And so it's not that interesting to talk about. Like, there's no big challenges there. We know how to share data over the network. Like user space subscription versioning notwithstanding, it's pretty trivial. I'm also going to, at some point, have to make this thing play nice with user space permissions whenever they come out. That's going to be a whole thing because we might not know the actions that this will run ahead of time. So we have to dynamically ask the user, and we'll see how that shakes out in the end. So that's it. I'm going to keep chipping away at this thing for some time to come still. I'm going to make sure I get the developer experience just right, get the core of the engine just right, get the user experience just right. There's going to be a lot of work to do on this. The developer experience, I think, is particularly important because there's a real risk that writing a yard file is just a 2-hour slog of wading through the boilerplate and just hashing it out, right? I would like a little DSL. The build system doesn't currently support it. Who knows, by the time I'm done with this, I'll be able to do that. Yeah, if you have strong opinions about this, do come talk to me. That's definitely going to be productive. I would be interested in hearing your thoughts. If you just want to look at the code I used for the demo, it's in the suite on the WIP then branch. Then was an older working name, and I have since repented of my sins. And yeah, that's it. Thank you so much.
Since you're trying to be friendly to users, what ship can I download this from?
Well, here's the friendly part. We prevent you from hurting yourself by installing it.
So no.
No.
That's the unfriendly part.
What can you hurt yourself with?
It's not, like it doesn't, like the most it ships with is a yard for pals right now. You can't really hurt yourself with it, but the user experience is not good at all. Like I wouldn't publish this, right? The source code is out there if you want to take a look. But I wouldn't want to risk having, normal users install this thing.
So when it comes to complex branching, it seems like it could be almost maybe trivial to have a bunch of different triggers or hooks, and then one component of a more complex, if this and that thing, would just re-trigger the same auto app. Is that something that has obvious problems that there's a reason you don't want to do that?
Well, so that was actually in the first prototype. I had this very advanced thing of triggers can trigger each other and learn things about themselves. This sort of still affords that in that you can send pokes. And so flows that are manually triggered, yeah, you can definitely generate a poke that triggers those flows. So it's certainly, it's certainly possible in that sense. But that doesn't quite feel like it's a cohesive part of how you construct these things. So that's what I want to move towards.
What is a ship?
Oof, well, I guess my assumption was wrong then. A ship is an Urbit. So it's your personal computer.
Okay.
So I guess you're thinking of a DSL in terms of a DSL that would generate yard files? Is that
Yes.
So have you given thought to, in conjunction or maybe instead of a DSL, jump straight to a UI experience for generating yard files?
Interesting. I have not. We should talk more.
No immediate question to ask because I have many immediate questions to ask. But package management, I want to talk to you about that after. Anyway.
Yeah, we'll do it.
Anyone else?
Do you see this as a full no code thing, or would somebody graduate from a really complex integration on this to turning it into a full app?
Yeah, that's definitely once you get to a world where it has all the features I put on the wish list, it's definitely a very power user centric, no code in some sense environment. And then yes, if you can bring your own small pieces of Hoon code for small components in your flow, then that gets you developing something, right? There's definitely a path here where people learn about Hoon by looking at other snippets of Hoon code that people have shared for this thing. It's a little bit difficult to see how that how you make the step from that into full-on Gall application developer. But also maybe as the Gall model evolves, these things get closer together.
Maybe there should be an export to app button in the UI for this.
Yes, that's a fun idea, actually. No more questions?
All right. Well, let's give it up for palfun-foslup, everybody.
Thank you. Thank you.